Alright, here we're going to be talking about rational functions, basically the definition of a rational function and some of the features of the graph of a rational function, which is the asymptotes of the graph. Alright, so first off, the form of a rational function. If you know what a rational number is, it's a number that can be written as a fraction. So a rational function has the same kind of definition. Right? A rational function has the form r of x equals p of x over q of x, where p and q are both polynomials. Right? So if you watch some of the other videos I did about polynomials, hopefully you know what a polynomial is, right? It's when you have numbers multiplied by x's raised to positive whole number exponents, and then several of those added or subtracted together make up polynomials. So if p and q are polynomials, and you take those two polynomials and you put them in a fraction, one above the other, you've got what we call a rational function. Right? So a rational function is basically a fraction with polynomials in the numerator and denominator. All right, so that's what the definition of a rational function. Now, one of the attributes of the graph of a rational function is that most rational functions have asymptotes, right? And we have vertical asymptotes, and we also have horizontal asymptotes. All right, so first up, the vertical asymptotes. The line x equals a is a vertical asymptote if y approaches positive or negative infinity as x approaches a from the right or the left. All right, so vertical asymptote is a vertical line. Now, if you recall, the equation for a vertical line is x equal to a number, and that number, that a value, is just the x coordinate of any point that vertical line goes through. Right? All the points on that vertical line have the same x coordinate, which would be a, just whatever number a happens to be. All right, so the vertical asymptote is a line. Its equation is x equal to a number, and what makes it a vertical asymptote is as the graph of the function approaches that line, either from the left side or from the right side, the graph either goes up towards positive infinity or the y values go down towards negative infinity. And we should see here in these four different pictures the four ways it could go. So here, my vertical asymptote at x equals a, that dotted line going straight up and down, and y is approaching infinity, right? The graph is going up towards infinity as x approaches a from the right side. Right, so as the graph gets closer to a from the right side, y just shoots off towards infinity. It just goes up forever, and from there, right? Or as x approaches a from the left side, so as we're coming from the left side now, the graph goes upward and y approaches positive infinity, right? So that's y approaching positive infinity from the right and from the left. But y could also go towards negative infinity, meaning the graph goes downward. So here in this picture, as x approaches a from the right side, y goes down towards negative infinity. The graph just drops and keeps going down forever. And then on the last one here, as x approaches a from the left side, so going this way, as you get close to that vertical line, that horizontal asymptote, the graph dips down and y approaches negative infinity. Right, now, the thing about vertical asymptotes is that the graph can never cross the vertical asymptote. The graph of a function will never cross a vertical asymptote. All right, so if you have a vertical asymptote, the graph just goes off towards infinity there. It never actually crosses over that vertical line, right? It might go to infinity on both sides, but at that point where that vertical asymptote is, the function is not defined, right? So it's an important thing to keep in mind. At a vertical asymptote, your function is not defined. The graph never actually crosses over the vertical asymptote. It just jumps from one side to the other. Right, and it could go a couple of ways. It could go, well, both sides go up towards infinity, or one side goes towards negative infinity, the other side goes up towards positive infinity, or maybe both go down towards negative infinity. Right, in some other videos that I do, we'll talk about finding asymptotes and figuring out where they are, and then also what the graph looks like as you approach an asymptote. Right, so this video here, we're just talking about the basic definitions of these things. Right, so that's a vertical asymptote. As the graph approaches that vertical line, it either goes up towards positive infinity or the y values go down towards negative infinity, and it does that on either side of the asymptote. Right, so either side could go either up or down. All right, so that's a vertical asymptote. A horizontal asymptote. All right, the line y equals b is a horizontal asymptote if y approaches b as x approaches positive or negative infinity. Right, so again, a horizontal asymptote is a horizontal line, and if you recall, the formula or the equation for a horizontal line is y equal to a number. And in this case, that number, that y equals b, that b is just the y coordinate of any point along that line. Right? All points on a horizontal line have the same y coordinate, and whatever that y coordinate is, that's the number you would put in there for b. All right, so horizontal asymptotes are all about what happens either far off on the right as x approaches positive infinity, or far off on the left as x approaches negative infinity. Right? The horizontal asymptotes have nothing to do with what happens for finite values of x. Right? It's only as x approaches positive or negative infinity, way out at either end of the graph. Right? So there's two. Well, it can go in one way or the other. So as x approaches infinity, as we move off to the right, as that graph, if that graph keeps getting closer and closer to that horizontal line, then we say that that horizontal line is a horizontal asymptote, right? So the graph can approach that line and keep getting closer and closer to it. We call that line a horizontal asymptote. Or on the left side, as x approaches negative infinity, as you move way off to the left, if the graph keeps getting closer and closer to a horizontal line, then that horizontal line is our horizontal asymptote. Right? And again, in another video that I do, I'll talk about, well, how do we actually figure out where the horizontal asymptotes are, where the vertical asymptotes are. I'll take you through that in another video of actually calculating them and finding the equations of those lines. One more thing I want to point out, though, on the horizontal asymptote. I said up here for the vertical asymptotes that the graph cannot cross the vertical asymptote. Right? On a vertical asymptote, the function is not defined, so the graph never actually passes through that vertical line. For a horizontal asymptote, the graph can cross the horizontal asymptote, right? You see on this example here, or this little picture I drew here, over on this side, the graph actually crosses that dotted line, right? It crosses the horizontal asymptote, but as it approaches out on the left side, as x goes towards negative infinity, that's when it keeps approaching the asymptote without actually touching it. Right, so it's a common misconception people sometimes have, well, the graph can never touch the horizontal asymptote. That's allowed, right? It can happen, and it does happen sometimes. Remember, the horizontal asymptote is all about as x approaches positive or negative infinity, just way off on the right side, way off on the left side. In the middle here, for finite x values, the graph can go over top of that horizontal asymptote many times. It's just that when you go way off to the right, that's when it approaches that line. All right, so those are the definitions of the vertical and the horizontal asymptotes, the definition of a rational function. And like I said, check out the other videos that I'll do, and we'll do some where we actually find the asymptotes and then I'll actually draw the graphs of rational functions.